Hello, this is our first drawing for the practice drawings for the T level. So I've just looked at this drawing just to make sure that we capture some of the challenges we could have when we're doing our ESP or the occupational specialism in the T level for design and development in mechanical engineering. We shall do some of the proposed past paper questions, but let me start with this one, which is a bit general. So this is a bearing puller, and the top part is called the main bridge. Then we have these other parts, which we will do those two parts, and then we do the assembly, and we also maybe show some bit of movement, which is typical of a project for the ESP. So, or the OS. So I put this one aside, and then I pull out a 2D drawing. As usual, we start by saving. I've already chosen my folder, which is to Mechanical Autumn. The students will have a similar folder or the same folder. So I call this one main bridge, and then save. This is very important because we don't want to keep saving as we go along. For fusion, this is saved once, and that will be throughout the drawing. Okay, so we start our sketch. We do the right plane, and then I'm going to make a sketch of cross section of that. And I think let me do without dimensions. So if we start somewhere there and go up to that point, then there. So this is part of the sketch. Then we start with dimensions. Start with this one here, 16. And then this dimension, 25. And then this dimension, according to the drawing there, is 15. Now, it is a curve from that point. We go to the arc, which is a tangent arc from that point, and go down. The dimension at this time, what we need to do is go to dimension here and put 85, which is the size of the arc. After you put that arc, we can trim this anywhere. May not be necessary, but then put it or 5 just that corner. So this should be all for the bridge itself. If we go to that line there and change to center line, then we go to revolve. Software should be able to pick it. We have a revolved shape already. So after we've done this revolved shape, all we need to do now is to draw we'll go to the underneath of this body, which is flat. And then we're going to draw a line. This one's an angle of 120 degrees. After that, we will offset chain and then offset this line. So let's put chain and see. Offset those two lines into that direction to minus 12.5. It should be half of that slot there. No, half of, sorry, of that bridge there. Gap. And then we have a fillet 5 millimeters in that corner. After that, we're going to cut off this external part just for the sake of completing it so that it can easily be recognized there. We just draw two random lines there. E4, extrude. Then all I need to do now is to extrude this one out. Let's say okay. So look at it from the top. That is the extrusion which it has created, and it is from that extrusion that now we're going to do the rest of the drawing. So that extrusion is in 3 positions. So we can do that by patterning. So if I go here, and go to, sorry, this one I need to push it a bit more down. If I go to pattern and then I put circular pattern, all I need to do now is to choose the feature, which is this. It is actually that cut, that one. Then I choose a circular surface. I can choose that. Then all I need 3 of them in quantity, full. I say okay. That creates the first shape of the bridge. After I've done that, I need to create that slot there. So can still use the bottom surface to my sketch. Now is to see there is this circle here. That edge is 21 from the center. Okay, so I can draw a circle anywhere. This one, and that circle is going to be the diameter of that circle is here 12. So 12, and there are 2 lines here, 10 mils each. So all I need to do is to draw a line going up. Then I offset that line both sides. Set that line. And I do 2 lines here. I do 2 lines. So I can just drop that one and set. I do both sides. Offset that line. Then that will be half of it, which is 5 mils. And then I have that. So all I need to do now is to trim off this. create that slot. I can leave this line there, but change it maybe to a center line or anything else. And then I can close off that. Because it's going out, I don't need to be very specific on where it's going to fall. E for extrude again. Give it a small angle. I click there, change direction. It should go up. Want it here, you could just say to object, and then you click on that surface. Should be able to go through. Didn't go through enough. Yeah, because I should have clicked on the top. So edit feature. Should have clicked on that surface there because it's the farthest. So that one now is the hole which goes through. From the slot, sorry. And we have three of those, but because we have holes on the side, so probably best thing is to deal with the holes on the side, and then we can be able to test. So I'm going to draw two holes space. Because this space, let me see, this space is inclined, eh? So it may be a good idea to draw the holes on the plane, which cuts through. Let me see. I don't think we need that. So if I click on that face, draw one hole here, random. That hole is going to be both of them are 80 millimeters actually. 8. Do another hole in the same line. That's also 80 millimeters. So this hole, one of them is going to be 25 and the other one 40 away from the center. And it's going to be 10 mil at the bottom. Okay, so from here to the center of this would be 25, and the other hole is going to be from here to there, which is 40. Then from here to the bottom, let's try this one, which I drew first, and see. Escape for any errors. 10 mils. If they don't move together, you need to put another 10 mils here. Then probably not very good drawing there because they should be able to move together. So after that, I'm going to extrude these two holes through both. I do E, then extrude cut, be able to come up to the next object, which is that. Let's see, okay. Look at this, the two holes going through. Okay, so we now have two holes. Then we need to do the hole. We can do the hole in the middle, or we can first duplicate all these all around. So what I need to do now is to duplicate this and that. So if I go to, again, I can push this one a bit down here. Then I go to pattern. Then I go to circular pattern. And then I choose the features. Select the features, which should be this one. And should be that. Those two. And then all I need is to get an axis. I will use this curve here. We need 3 full ones. And then I say, okay. So it again. Something is missing. Yeah. We should say full. Maybe the axis I selected was not a good one. Let me see. Select two objects selected. Then axis. Get the axis. Full. Then identical, and then I say okay. Okay. So that one cuts through all of them in an identical way. Now, in the middle of this, change this visual a bit to shaded with visible edges, because I was not seeing that mid part. So, oh, actually I can see even that the holes are going in too much, because it seems that when we're doing this sketch, I missed out one of the dimensions. So if I go back to edit sketch, this sketch here, that 21 is not there, which is from there to the center of this to there. That should be 21. I click OK. Now our drawing has already adjusted and it looks to be more of what I should have wanted. Okay, now in the middle of this we have an M12 hole. So all we need to do is to go to the hole and then select that face, the tapped hole, the normal hole, and then we scroll down here isometric, and we need 12. So we need the whole of 12. The only thing is to be sure that it's in the middle. If we just touch one of these edges as a reference, then it will be in the middle. The hole goes through. So we use here full thread, hole type, distance, and we put all. That should be able to cover that hole. Think there are any other features on that hole which we need to capture. And then we just say okay. Now I have the hole, which is properly tapped, and now all the other features as the drawing is. We may do other things, maybe put the material on the rest, but those ones we can do as we go on. Those are main bridge. Let's see the material, which is by default should be metal. The steel. Here are most of the steel. This part and the first video, and which actually presents the biggest issues. Okay, so see you in the second part of the drawing. Thank you.